Hello guys, this is the next lecture, which is the polymorphism and its type. This is the next article. So, let's start. What is polymorphism? Poly means many and morph means forms. Basically, to remember, it is like multiple forms. Polymorphism is one of the core principles of object oriented programming. It enables the objects to take on multiple forms, right? It allows the same operation to behave differently on different classes, enhancing code flexibility and reusability. This line that it allows same operation to behave differently on different classes, when you will see an example, code example, you will get to like learn it more clearly. You will be able to understand it more clearly. Okay, so let's talk about a real life example of polymorphism. Is a person who at the same time can have different characteristics. A man is at the same time a father, a husband, and an employee. So the same person exhibits different behavior in different situations. So this is called polymorphism, right? So a man at the same time can be a father, a husband, and an employee of some company. So same person is exhibiting different behavior. So this is like polymorphism in real life. So now what is polymorphism in Java? So in polymorphism in Java is basically of two types, which is compile time or static polymorphism, and second is runtime or dynamic polymorphism. Let's read about both of these one by one. So first is compile time polymorphism, which is also called static. So this basically occurs when the method to be executed is defined, determined at the compile time. So there are two runtimes, there are two times, right? One is compile time and another is runtime. So when the method to be executed is determined at the compile time itself, so that time which polymorphism takes place, that is known as the static polymorphism. So it how this is achieved? This can be achieved using method overloading or operator overloading. So method overloading is basically like a single method can be written into multiple types. A single method can be like have the same name and return type. It will just differ in the number of parameters or the data types of parameters. So when the multiple functions with the same name but different parameters, then the functions are said to be overloaded. Okay. Hence, this is known as function or method overloading. So, how can functions be overloaded? They can be overloaded by changing the number of arguments or changing the type of arguments. Okay. Next is changing the number of arguments. So first example, as you can see, we have a class vehicle. We have a start method over here. It has a string vehicle type. Now we are going to overload the start method. We can see the name and the return type of the method is same. We have just changed the number of parameters. So you can see this is string vehicle type and int speed. Now what will happen? This is main class. So at compile time, before any execution occurs, now it will automatically, Java will decide that for this method like start car, which one is to be called? This first function will be called, right? Because it only has a single parameter and it matches with its definition. Second, it has bike and 60, so this overloaded method will be called. So method to be called is determined at the compile time. So this is the example also. This is the main class. Main class uses the vehicle class. Vehicle class has two functions which are overloaded. Like the same function is overloaded. Correct? So now it was first of all we changed the number of arguments. Next we can change the type of arguments. Okay. So in type of arguments, how do we change the type of arguments? So we have a class vehicle, we have a start, we have a vehicle type. Now we can simply change the vehicle. So from string we changed it to int. So the function is now changed. So in the compile time it will already be decided that we have passed a string. So this function will be called. We have passed an integer. So overloaded method will be called. Okay. Similarly, yeah. So this is the class diagram. So method resolution happens at the compile time, and it provides us better readability and cleaner code by allowing methods with the same name to perform similar actions, because the kind of actions are similar. So instead of thinking about different methods names, we can simply use this overloading feature. So we do not have to worry about the method names. So for next is runtime or dynamic polymorphism. Runtime polymorphism occurs when the method to be executed is determined during the runtime. So it is achieved through method overriding and is closely tied to inheritance. Okay. So method overriding. So method overriding allows a subclass to provide specific implementation of a method already defined in its parent class. Okay. So we can provide a specific implementation, like overriding is this only, right? Like we have a parent class and a subclass. So a specific implementation of a method is provided in the subclass. So the overridden method in the subclass has the same name and the return type and the parameters as the method in the parent class. Only the implementation differs. So for example, this is the parent class, which is the vehicle, and this is the subclass. So car class extends the vehicle. Now this is going to override the start method, because for example, car can have a different start method implementation and bike can have a different start method implementation. So car is going to override this method and give its specific implementation and its version. Similarly, bike will give its own version of the start method. Okay, so we can now, what happens is, using the vehicle reference we can call the car object, and using the vehicle reference we can also call the bike object. Now what happens is, using the object type, like during the runtime, Java will check that object type is car, so the start method version of the car class would be called. Okay. And for bike, now we have seen that the object is of bike type, so the bike method version would be called. Okay. So this is basically defined by the object type or the reference type. So reference type is of the vehicle class and actual object is of the car class. So for example, if we had suppose any other method in the car class which was not present in the vehicle class, so what happens is, since the reference type is of the vehicle, it would check, oh, that we do not have this method in the vehicle class. So it will give us an error, because the reference type decides if the method is going to be called, because we have the start method in vehicle. So the implementation is called of the car class because it is the object type. But to determine whether the method is present or not, the reference type is decided. So to call that method, the reference class should have the method. Okay. So assigning a truck object, this is similar. So this example you can see, this is the vehicle class. All of these extends this class, car, bike and truck. They override these three methods. So method resolution happens at the runtime. So this basically support the dynamic method dispatch, basically dynamic resolution, enabling the Java virtual machine to determine the appropriate method implementation. So now what is the advantages? What are the advantages of polymorphism? First is code reusability. So we are able to write the generic and reusable code because we have a single interface to handle multiple types. For example, we have a interface vehicle, and using this interface we can have multiple types written. Okay. And you can see, using this vehicle as a reference we can call multiple start methods. Else what we will have to do, we will have to create an object for each class, like car equals to new car, then bike equals to new bike, truck equals to new truck, and then call the same start method for each object, car dot start, bike dot start, truck dot start. Here what we can do is, simply using the vehicle as the reference object we can call the car class, bike class and the truck class. So this is the polymorphic behavior. Next is, vehicle allows you to reuse the single loop to handle different implementations. Correct. Flexibility, it provides flexibility in the program design by enabling dynamic method behavior. Similar thing, vehicle dynamically assign different types of vehicles. So we have created one reference type. So vehicle, we created a new car, and actual object type is of car, reference is of vehicle, vehicle.start, similarly for bike and truck. So using the vehicle interface, we dynamically switch between different implementations at the runtime. Extensibility, yes, we can simply extend the code by adding the new classes or methods or overriding the existing ones. So we can override a method or we can simply add a new class, right? So we can class bus implements vehicle, so we can simply add a new class bus, and we can, without changing the existing code, we can add a new class, and the start method would also now work because the reference is of vehicle type, right? So adding new vehicle type is seamless and requires no major changes to the existing code because all new classes just implement the vehicle interface. So now what are the disadvantages? First is complex debugging. So what happens is during the runtime polymorphism, debugging can become a bit difficult because we do not know which object is now being called unless we do a use a debugger and call, we check line by line. So suppose here we have this loop, right? So at the runtime we have to determine which start method is being called and has some problem, like if any of the start method is not behaving consistently. So to debug which is the method causing the problem, we will have to use a debugger and go line by line at which call, because all of the classes have the same reference. So what is written: when iterating through a list of vehicle objects, it is unclear during debugging which specific subclass, car, bike, truck or vehicle is being called without stepping through the code or inspecting the runtime variables. So if the list comes from an external API file or database, the actual type of each object isn't clear from the source code, making it difficult to debug. Yeah, this is what is being said. For example, the list of this particular thing comes from the external API, so we do not even know what is the actual type of each object, right? So it will eventually make the debugging difficult because we are just iterating and we do not have the type of what is the type of object. We do not know whether it is a car or a bike or a truck. So if we do not know and the list is coming from an interface, so and all of them have the same method name, so it would be quite difficult for us to identify that for which of the class the the something mishap is happening, right? Second is performing overhead. So since we are doing dynamic method resolution, so since Java Virtual Machine has to resolve the method during the runtime, so it can have to determine which is the method. So class vehicle, it will start. Class car extends vehicle. So void start system.out.println starting a car, and we have a main class over here. So we have a vehicle and during the dynamic method dispatch, it basically shows us the difference, basically the how much time the JVM takes to basically resolve the method during runtime. So conclusion, polymorphism is a powerful feature in OOP that promotes flexibility, modularity and reusability. Understanding its types, compile time, runtime is essential for mastering OOP principles and designing robust applications. Yeah, so thank you.